Okay, this one here, we've got the integral, and it looks a little confusing at first, right? Like let's try and integrate just this guy here, that 1 divided by x. All right, and if you're not used to logs, if you're not used to logs, then you might think, oh, maybe this is just going to be equal to, I've seen one of these before, you just put the x as -1, right? And then use that thing where you say like x -1 plus 1, and then you divide by the -1 plus 1, and then don't forget the plus c. But you hit a problem. Have you seen it yet? It's x to the power of 0. That's not your problem. But anything divided by 0, right? That's your problem. It just breaks maths. We don't know what it is. It's just undefined. We don't know. How many times can you fit nothing into something? This breaks it, right? So you can't do this. Okay, so there's, as soon as you see that, right, when there's just an X down the bottom there, and the other giveaway telltale sign is that this 3 and this guy here are the same. So you're thinking, aha, it is logs, right? Because when you differentiate ln, so when I try and find the derivative, right, of, oh, sorry, when I try and find the derivative of 1 over x, ln, this is going to give me that 1 over x. And so the reverse is very true. When I integrate 1 over x, that gives me ln x plus c. But now you're asking, what happens if I add like a 3 here? Let me change the color. What happens if I add a 3 there? Well, then the 3 must also be put into here, and then we must also divide by that 3 as well. Cool. So what the trick here is, right, is that really another way of expressing this, the true form, is by having, if I have, I try and integrate, or if I try and differentiate ln, and then I say like some function, I don't know what it is, then what we say is that function down the bottom is normal, but we find the derivative value of it at the top there. So we can see that like x normally for this top one here, that there is like the normal function is x, and when we differentiate x, we get a 1. So that's the whole idea here, is that you're going to see that pattern. Cool, so that's enough about the details of it. Let's go into actually solving this question. So hopefully what you see is, right, that divide by 3, 3x minus 2 dx, well, you know, okay, it must be, ln of 3x minus by 2, right? Okay, and then when we go backwards, when we differentiate that, we get a 3x down the bottom, and we differentiate this function here, and we're just left with the 3 at the top. Cool, we don't need to times by anything or divide by anything. That is it. So you don't need to say like, oh, all divided by 2, for instance, because sometimes they can add that in to make it more tricky. And that is your final answer right there. So hopefully that makes sense. We've got tons of exam level questions just like this one that could pop up in your next test or your exam. So practice those questions that you're likely to encounter. Don't practice the ones that don't really teach you anything. Like sometimes the textbook questions go on and on, like 40 questions of the same thing. Go do something else. Go learn, push yourself. So these questions here on my website, they've all got hints, solutions, and videos, all for free. But if you're still stuck, we offer tutoring as well. In person, online, or group, we'd be happy to help. So reach out. And if you found these videos good, like it, subscribe. I'll be releasing them hopefully almost every day.